everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over absolute value inequalities, and I like to say that this is an absolutely amazing topic. Anyways, so let's take a look at the steps we need to do to be able to successfully complete an absolute value inequality. So first, it's always important to know what is absolute value. I'll make another video on absolute value equations at some point, but absolute value means the distance between 2 points or 2 items, whatever, and this distance cannot be negative. So if we have a negative number within our absolute value, it changes into a positive number. This is not saying, though, if I have an equation like x minus 5, that becomes x plus 5. That's not correct. That means if I have a value and it's like negative 5 away on a number line, its distance is the absolute value, which is a positive 5, because we can't have a negative distance. That doesn't make sense. So now let's apply that into a inequality and solve. So our steps are really important, our little rules are, we are going to get rid of the absolute value bars. Once it's just the absolute value bars greater than or equal to, less than or equal to, greater than, less than a certain number, and we get rid of those absolute value bars, and we set it equal to the regular equation. The other step is to get rid of the absolute value bars, flip the sign of the inequality, and change the sign of the number. So let's say the number was let's say the number was 5. Now it's going to become a negative 5 on the right-hand side or whatever side doesn't have the inequality or the absolute value. But first, we're going to have to add or subtract, then divide by the number that's attached to the absolute value bars. A lot of my students make the mistake of distributing in the number that's attached to the absolute value. That's not correct. These are not parentheses. These are absolute value bars. You can't distribute in. So if there's anything like a normal equation where we're adding to it, subtracting to it, multiplying the absolute value bars by something, you need to move that all over first, and then we can break it up where we keep it regular, and then we flip the sign of the inequality, flip the sign of that constant on the other side. So we have to perform the operations first like we normally would for an equation, and then we are able to do the rest. So that was a lot of talking, but let's see what this really means. So our starting question is here. We have a lot of 5s here. I guess I love the number 5. But we have all these 5s here, and it looks a little bit more intense. And this is a more challenging problem, but this is something that we can all handle, especially after watching this video. So just like a normal equation, if I was given something like negative 5x minus 5, I would add the 5 over first. Well, it's the same thing. We do addition and subtraction first, then either multiplication or division, depending on the problem. So I'm going to add 5 to both sides. So I add 5 and add 5. So I get negative 5, I'll write it over here, absolute value bar, negative 5 minus r is less than or equal to, this gives me negative 20. So far, so good, right? Now, some of my students make the mistake where we distribute in that negative 5 into the absolute value bars. That is not correct. Not going to work. We are going to think of it almost like negative 5x. Well, to get rid of that negative 5, I divide by negative 5. So let's divide both sides by negative 5. But wait, when I divide by a negative number, for inequalities, that changes the sign of the inequality, right? So I have to do the same thing. No matter when I divide by a negative, I have to flip the sign. So I'm going to have my absolute value bars, negative 5 minus r is greater than or equal to, I flip that sign because I divided by the negative, 4. So now I have my absolute value bars, my inequality symbol, and my constant on the right-hand side. This is where we continue, where I said we break up the equation. So when I break up the equation, I'm going to have on one side negative 5 minus r. So I keep what's on the inside of the absolute value bars. I keep the inequality the same. It's greater than or equal to 4. And I'll solve this equation. And then the other one's going to be negative 5 minus r is less than or equal to negative 4. I flip the sign, I flip the sign. We're flipping the sign a lot in these problems, and if we miss one flippage, this whole problem is going to be wrong. So we have to be very careful that when we're dividing by the negative, we flip the sign. When we're splitting it up, we flip the sign. So let's solve this problem. I add 5 to both sides, I add 5, and I get negative r is greater than or equal to 9. But I don't want negative r, I just want r. So once again, we have to divide by a negative, which means we flip the sign. So I'm going to get r is less than or equal to -9. Do you see how we flip the sign so many times? That's okay. It's fun. Just going in a circle. So I get r is less than or equal to -9. Let's solve this one. I add 5, and I get negative r is less than or equal to 1. Gotta divide by that negative, which means I flip the sign. R is greater than or equal to -1. So now let's graph that to see if this is an or an and statement. So I have r is less than or equal to -9. -9 is right here. It's a closed circle. And I'm going this way. Then I have r is greater than or equal to -1. Closed circle again. I'm going this way. So this is an or statement, so I put or in between. I would circle off this as my final answer. Of course, I make you do interval notation. So just make sure you know how to do interval notation for this. So once again, this was a lot in one problem, but it's important to note that we have to flip the signs every time we're dividing by a negative. Let's take a look at another problem to see how we would complete it. I wanted to show you this problem because it is a little bit different from what we've seen prior to the last problem. We now have -5 plus 8 absolute value less than or equal to 91. Sometimes people will take the -5 and add it with the 8. Wrong, we can't do that. It's almost like putting -5 plus 8x and adding the two together. They are not like terms, so we are not going to add them together. We're going to do the same steps as before, where we add or subtract first. Because this is a negative, I am going to add it over. So I get 8, absolute value of 7b minus 9 is less than or equal to 96. Then I divide by 8, and I get 12. So I get 7b in my absolute value minus 9 is less than or equal to 12. We're all good. We can continue. I didn't divide by any negatives, so I didn't have to flip any signs yet. The 12 is positive, so I don't have to think about rare cases. A little spoiler alert, we're going to do that next. So I'm going to continue. So I'm going to leave my absolute value in sides as the same. So I'll have 7b minus 9 is less than or equal to 12. And I'll have 7b minus 9 is greater than or equal to -12. And I'll solve the two. So I add 9. I get 7b is less than or equal to 21. So b is less than or equal to 3. Same thing for the next one. I'm going to add 9. So I get 7b is greater than or equal to -3. So b is greater than or equal to -3/7. We'll graph it to see if it's an and statement and how to continue it. So if b is less than or equal to 3, once again a closed circle. If it wasn't or equal to, we would do an open circle. And I'm going this way. Then I have b is greater than or equal to -3/7. Well, -3/7 is almost halfway through 0 and -1. So I'm going to put it like right here. And it's saying it's greater than or equal to. So they are attaching. They are attaching, so this is an and statement. And I have to write that. I make this little silly thing as a sandwiched answer. So I put my smallest, which is -3/7. We do the symbol this way. It's or equal to. We're going to say b. And then is less than or equal to 3. Which if we look, b is less than or equal to 3 is here. B is greater than or equal to -3/7 is here. So we are good to go. So hopefully this was helpful to figure out what we do if we have our constant term that we have to add or subtract. In the front, we can't combine those two. We just continue solving our equation like normal. Let's take a look at some of our special cases so you understand how to complete those. One more problem we have here. We'll do another one after, but here's another problem. We have -8, absolute value of 9n plus 6, minus 10 is greater than or equal to 86. Let's start off like normal. I am going to add 10 to both sides. Add 10. And I get -8, absolute value of 9n plus 6. And then I get the greater than or equal to 96. Once again, we have that 96. We can put in our calculator, 96 divided by -8. We just saw 96 divided by 8. Wow, same numbers. And I get, we're dividing by a negative, so I have to flip the sign. I get 9m plus 6 in my absolute value bar, negative 12. This is where we have to stop. Uh-oh, we must stop. We have a negative constant on that right-hand side. We didn't see that before, because remember we have to split it up, change the sign, and when we changed the sign, that constant became a negative. But wait, that's a negative, right? We have never worked with something like that in the past two problems. So let's look. We have to think about it. Is our absolute value ever going to be less than or equal to a negative? No, it's not. Absolute value cannot be negative, so it can never be less than or equal to a negative number. So my final answer is going to be no solution. You cannot have an absolute value number, when we solve that, be less than or equal to negative 12. For example, even if I plug in negative 100 into absolute value, so the absolute value of negative 100, the answer is 100. It's never going to be less than or equal to negative 12 because distance can't be negative. So my answer is no solution. A way to remember this is absolute value. We have the absolute value bars either less than or equal to a negative number every time it's no solution. Let's take one more look at one more problem to see what we're going to do. For our last problem, we have this here, negative 10 minus 10 absolute value, 6a plus 4 is less than or equal to 70. Once again, we add or subtract first, so I'm going to add my 10 over. And I get negative 10 absolute value of 6a plus 4 absolute value less than or equal to 80. All right, now I have to divide by that negative 10. So I get 6a, this is absolute value, plus 4. Just write over this to make sure you can see it. 6a plus 4, divide by a negative, so I have to flip the sign. And that's going to be negative 8. Once again, once we get a negative on that right-hand side, we have to stop. Stop. What is going on here? So I have to think about it. Is my absolute value going to be greater than or equal to or greater than negative 8? The thing here is you're like, no, it's never going to be equal to negative 8. But we have to think about that other option. It's or equal to. So we don't have to just think about the or equal to. We think about the greater than. So because our absolute value is always going to be greater than negative 8, because it's always going to be a positive number, this is going to be infinite solutions, or some people say all real numbers. This is going to be infinite solutions because absolute value, distance, is always going to be greater than or equal to, but I know it's just greater than a negative number. So my answer is going to be infinite solutions. And when we have infinite solutions, we shade the whole number line. So this would be our answer. Infinite solutions are all real numbers. We shade the whole number line. So the key point here is when we have our special cases, if we are having greater than a negative number or greater than or equal to a negative number, it's infinite solutions. If we're having less than or equal to, it's a no solution. So that's the one little difference between inequalities and equations, where equations, it would just be no solution. But we have to look at the final step, because if I just stopped here, I would say, no, this is positive, I'm good to go. You have to do it at the final step where we just have the absolute value bars, the inequality, and the constant. So I hope these problems were helpful to figure out how to solve absolute value inequality.